So you have been working on Chapter 9 and you are looking at contingency tables for the chi-square distribution. So we're still on Chapter 9, still looking at the chi-square distribution. This time we're going to be looking at the second type of chi-square test, which is the goodness of fit test. So we did contingency tables, now we're looking at goodness of fit. Now the goodness of fit test, this is not going to be a table, it's going to be one sample, and we're just looking at that one variable and seeing if it fits the predicted distribution. So there's only going to be a single list of values here. Just like the contingency table, it's going to be a set of counts, except there's only going to be one variable instead of two variables. Okay. Now there's going to be two different situations that we're going to look at. And for this video, we're going to look at the null and alternate for each. They're very similar to each other, but there's one slight difference you're going to have to add to the null when you write out your null and alternate. So again, they're going to be sentences. So let's look at the two examples. Roulette wheel has three different colors on it, and each color has an equal chance of getting hit. Test the claim being 95% confident. And we have red, black, and green, and the observations, how many times they fell. Now, if you don't know the game of roulette, this is where in the casino you put your money on a number or color, and they throw the ball around a wheel and see where it hits. Well, there's usually three colors, red, black, and green. Now, obviously, you can see this and see that they are not equal. We're just saying, we're using this just as an example to go through our steps here. So we're looking at the null and alternate. The important part here is it says each color has an equal chance. That equal chance means that red, black, and green all should have very similar values in it for the observation. So our null has to show that they are equal to each other. So the way I'm going to write this out, the distribution of colors is uniformed or evenly. You can use either the term uniformed or evenly. Uniform just is another word of saying that it's similar all the way across the board. Okay, so just make sure you have the variable in here. I'm talking about the colors on the board, so the distribution of colors is uniformed. For the alternative, we're saying it's not going to be a direction, one higher than lower, because there's actually more than one category here. But we are going to look at just at least one is not equal to the rest. So that at least one is the important part. At least one of our categories does not fit. And I think it's kind of obvious the green is the one that's not fitting in this case. Okay, so take a second and look at my null and alternate. Everyone's null and alternate should be very, very similar to each other. You don't need to venture off and write a paragraph. Just a very simple, this is uniformed. And for the alternate, at least one is not equal. Make sure you're stating the variable in the null. Now in this case, it said the colors have an equal chance. That is important to note. Okay, for this example, Joe bets thinks the closer a horse is to the inside of the track when he starts a race, the better chance he has of winning. Below, he made a list of the chances the horses have of winning depending on where they start. Test shows claim at 99%. Now this time it's not saying position 1 to 8 has an equal chance. It's giving us a percentage for each one, and each one is different. So really what you should do is write out each one equal to that percentage. We don't need to do that. We're just going to assume, okay, this is the distribution we're predicting. This is the distribution that we assume the horses fit that we are for the positions, for the winning position. So when I write out my null, since it's not even or uniform this time, the position of the winner fits the assumed distribution. You don't need to write out each percentage for each position. Just we have it there in front of us, so it fits the assumed distribution. And again, we're talking about the variable position of the winner. For the alternative, it's very similar to last time. At least one position does not fit. Okay, so at least one of those is not correct. So either the 1 is not actually 30%, the 8th position is not actually 5%. Be careful on this. The count, the observation is over here, 50, 42, 41, 38, down to 16. These percentages go with each one of these positions. The 30% is not a part of our expected value, but we will need those percentages. Okay, so there's our null and alternate. So make sure you look at them. It's not an equation this time again. It's going to be a statement describing what the distribution is. Either fits the assumed distribution, that's if they give you all percentages, or it is uniformed or even. And really there should be a big hint. This one, it has a term equal chance, okay? And there's no percentages for each category. It just says equal chance. For this one, it's giving you a percentage for each one of those. So that's why you need to read the problem and identify the information that they're giving you. That will give you a hint of how we're going to get our work to find our p-value. Okay, so there's our null and alternate. Just like for the last week or so, that is your first step. You need to have a null and alternate to start your hypothesis test.